Thank you, Leonardo. So yes, obviously this talk is going to be in English, with apologies to everyone who doesn't speak English directly. I could try to do it in Spanish, but it wouldn't be good for anyone, let's be honest. My name is Babak Javadi. This is Keith Howell, and we're here to talk to you about some alarm system stuff that we've been doing recently. So first, let's talk a little bit about ourselves. I am a lot of different things. Wow, this screen is not super happy with this font. Raise your hand if you can't read the screen. Fuck. All right, let's see what I can do to figure this out here. I apologize, guys. Don't worry. All right. Well, here's what we're going to do instead. I'm just going to be extra clear in my reading. Thankfully, we have a lot of photos and some video. Not too much text, but we'll just have to keep going through it. I do apologize. I wasn't expecting a low-resolution screen. So, I'm kind of a hardware hacker of sorts and security researcher. I have a pen testing company called the Core Group. I'm also involved with an organization that a lot of you are probably already familiar with, the Open Organization of Lockpickers, or TOOL. Who knows about TOOL? Okay, most people here, yeah. We've, Deviant, unfortunately couldn't make it this year, but we have been here in previous years talking about lockpicking, and this year I'm here talking about something a little bit different. Keith, you want to say a little bit about yourself?
Yeah, I was, many years ago, I was an electronics engineer in the Army, and I've been a network engineer for a rather large ISP that's now out of business, UUNet Technologies. Has everybody heard of UUNet at some time?
No.
No?
Right.
Okay. I now do security assessments for contract work, and I work for a company called Assurance Data in Virginia.
So, yeah, that was who we are. Very boring stuff. So let's get to the fun stuff, eh? So, alarm systems. We're going to cover some basics first. This stuff, we're not going to get too technical. There's a lot of technical background, and we're going to touch on some of the things. But we're going to try to give you the best overall picture possible. So first, we're going to talk a little bit about your average alarm system. So in your average alarm system, you have a system panel. You have a keypad that you use to arm and disarm. You have a number of different sensors, door sensors, motion sensors, usually a siren or sounder of some kind. This device here, which you can't see, you probably just see a small line. This is actually this little RF receiver here with antenna you can see on stage. And then also, you have wireless remotes and stuff. And again, white on white, I realize it was probably not the best design choice on my part. But there are different wireless components that you can install in an alarm system in situations where running physical wire may not be possible. So those are your basic components. And then obviously everyone knows that an alarm system is not an alarm system unless it can call someone. So your alarm system is connected to the central office to usually an Ademco modem, which is this guy here. I'll talk a little bit more about him later, but this is a very advanced piece of technology that's used by almost every alarm system today. It's a dial-up modem. Who can tell me the speed of this modem?
Go on. Guess.
2400 baud. It's a Hayes 2400 baud modem that you too can buy for the low price of $150 US. But anyway, well, let's get on with it. So the first major thing to understand about alarm systems is the ECP Bus, which controls all the wired components in the system. It connects the keypads to the system panel itself. And Keith is going to talk a little bit about that bus, also known as the Expanded Console Protocol Bus.
Yeah, we started doing the investigation and we came out and found we have just 4 connectors on the bus. The ground, 12 volts, data, and data out. We've got it colored here because that's the color of the wires that they actually use when you're hunting around looking for these cables. It's a protocol that's very similar to RS-232. If you can see the trace from the scope on the side here, you can't read it, but the voltage is identical to an RS-232 voltage. And that's how we started investigating it. And we found that it's a protocol that's almost RS-232, but it has violations that prevent standard tools from actually doing that identification.
So we're not going to go into great detail about the ECP protocol. I can't say it's well documented. It's well researched by a lot of other people. If you are really curious about that stuff, there's a wonderful article in the magazine called Circuit Seller, which is a great electrical engineering type magazine. Issue number 201 had a great article about the ECP bus. And we interface with it with this thing.
This is a device that was designed and built by a gentleman called Sean Matthews in the United States. And it's an interface between the ECP bus and a USB port. It uses a standard FTDI chip, so you have any standard serial program, either Windows, Linux, whatever, will talk to it. And the 4 connectors on the front that you can see, those go through to the alarm bus itself. And it presents all of the alarm data in serial format. And it copes with the protocol violation. And you can see on the bottom there, that's a virtual keypad. We'll show you later on the screen. This behaves exactly the same as any other keypad on the system.
Yeah, it's actually a really cool tool. Who has an alarm? I guess it's not very common here. Who has an alarm system in their house here? All right, so a couple people. It's much more common in the U.S. Is anyone here involved with a business that has an alarm system? No? Okay, all right. You guys have seen the blue ADT signs around, probably? Everyone has seen an ADT sign? This is what we're talking about. So anyway, this is you can, if you want to talk to your alarm system with your computer and have a virtual keypad, this is what you would use. It's third party. It's not made by Honeywell or Demco, but we're using it as a research tool, and it's allowing us to interface directly with the ECP bus. Hardwired zones. What are hardwired zones? So a hardwired zone in an alarm system is any copper loop that connects to a motion sensor of some kind. I don't actually have any hardwired sensors here. This particular one is a wireless sensor. But if you have, here we go. Here's a hardwired sensor here. This is a high security magnetic contact sensor for a door. And you've got some wires leading out of this. And a hardwired sensor, this sensor would have to go all the way from wherever that sensor is installed. It'd have to run all the way to the panel. So that's potentially a lot of wiring, a lot of drilling, and a lot of people are unwilling to do that for cost reasons or practicality reasons. And as such, the RF stuff is sometimes used. But this is, you don't have to memorize all this stuff. This is actually what's printed on the inside of the panel there. It just shows how hardwired zones are supposed to be hooked up. Depending on what model of panel you have, you're going to have anywhere between 6 and
40-something zones.
40-something zones. And that, when you see an alarm go off and it says, zone 1 or zone 2 alarm, that's what it's talking about. It's actually talking about physically which zone it's hooked up to in the alarm panel. These are all terminals. These are all physical copper loops inside the alarm panel that you hook up sensors to. So the zone consists of a copper loop. Hardwired zones are used for a lot of things. They're used for smoke detectors, tamper switches, magnetic door contacts, motion sensors, glass break sensors. They have special sensors that detect the frequency and sound profile of glass when it breaks, so it can discern between like a bump and, say, the sound of glass cracking, which is really cool. Photoelectric beam break sensors, or IR laser beam break sensors. So if a car goes through or if someone trips it, you can set that off. And also pressure pads. They also sell weight-sensitive pressure pads. So if you walk over an area of carpet and you weigh more than 10, 20 pounds, then it also will set off an alarm. So there's a lot of different cool stuff you can do with a hardwired loop. The loop operation is pretty simple. How does that work, Keith?
It's a loop. It's a current sensing loop. So you can see the terminals at the top. You've got is everybody familiar with electricity, how it flows? We've got the positive to the negative. So in these, we've got two loops here. We have the positive side, comes down through the contact and back, and the same with this loop. So this is actually two distinct loops on the system. And one of the important things to note is down here, this is called EOLR, End of Loop Resistor. And here's the problem. It's supposed to be the end of the loop.
Yeah, and we'll talk about more why that's important on a later slide. But.
And we'll get to that, but remember the term, end of loop. And we have two types of loop. There's a supervised loop and an unsupervised. It's just how the alarm system determines whether it's an alarm or how soon it's going to set the alarm off. Fire alarm is a supervised loop. It will basically alarm at any time, even if the system is disarmed. That's basically the difference.
Yeah, there's different types of sensors. We don't have to get into too many details. There's normally closed and normally open. That determines whether or not, in the default state, if there is a electrical connection, is it closed or is it open by default? And every sensor can be different. Some sensors can be wired in either way. It's not relevant for the scope of this specific talk, but we mention it just so everyone is aware there's different types of sensors available.
And for anybody that's an electrical engineer like me, normally open and normally closed are reversed in alarm system terminology.
So if you are double E and you're curious about this stuff and it doesn't make sense, talk to us and we'll explain why they basically broke all of the rules and did things their own way. There's also wireless zones. So those are hardwired zones. Those are traditional zones. There's also wireless zones. And with the wireless zone, you have your alarm panel here, and then you also have a RF receiver, or RF transceiver. That's what we have here with the cover off, with the little blinking lights and little cute antenna. And the RF receiver is connected to the alarm panel via the ECP bus, so it's wired in. And then it has the ability to communicate over a wireless frequency. In this case, it's 345 megahertz with the other devices. And we'll talk about more why that's interesting a little bit later, but that's basically all you have to know for now. So wireless device state identification. What do I mean by that? So every wireless device, whether it's a remote control or a door sensor or a motion sensor, whatever it is, if it connects to the wireless system in any way, there are three pieces of data that are transmitted every time there's a transmission from the wireless sensor to the receiver. The three pieces of data are the device serial number, which is unique to every device. It's set at the factory and can't be changed, kind of like a MAC address. The loop status, which
they've taken terminology from hardwired loops and applied it to RF sensors. So it just makes the installer's job a bit easier.
Yeah, if some of these words don't make sense, it's not just you. They didn't make sense to us either. And we've only been looking at this for 6 months, and so for us it looks normal, but it is fucking stupid. So there is a loop status. All you have to know is that there's 4 loops per device. And that doesn't make sense right now, but it will in a moment. It's used by every RF device, including door sensors, glass break sensors, wireless keypads. They even have wireless sirens. So, for example, if you need to install a speaker to make that like whoop, if you can't wire a hardwired loop to it, you can put that somewhere else, and it can send a wireless signal to that speaker to activate the siren. So already you're wondering, I wonder if I can spoof it. Yes, you can, but we'll get to that. So serial numbers, as I mentioned, they're non-changeable. They're supposed to be unique, just like a MAC address, and they are enrolled during programming. So rather than programming the serial number into the wireless sensor comes from the factory with the serial number already on it. In fact, it's on a sticker right there, and you're supposed to take the sticker off, obviously, once you install it. But every device, every remote, has a serial number on it. This one's hidden over here. And during initial programming, when the installer is setting up the system, you actually program in the serial number of the sensors into the alarm panel, so the alarm panel knows what to recognize as a valid signal. So we're just going to leave that right there. There we go. So that's kind of, honestly, I like messing around with wireless stuff, and that's one of the things that really I was interested in. When I saw Keith first talk about alarm systems in general at ShmooCon last year, what got me the most was the wireless stuff. I want to fuck with the wireless stuff, right? Like, because that's the cool stuff. That's where you can do that stuff from a distance. You want to understand how it communicates, can you intercept it, all this other stuff. So there isn't as much documentation as there is on the ECP bus. There isn't equivalent documentation for the wireless stuff. No one else has really researched the wireless communications of alarm systems that we found publicly. It's obviously other people may have, but we couldn't find anything. So the first thing we did is we hooked up a logic analyzer to the circuits inside these devices and had them talk to each other. And we stared at it's all binary. It's all unencrypted, clear text. It's just binary strings. And we stared at it for quite a while, comparing information in order to understand what's going on. So everything that we've done here, we've decoded ourselves. And since you can't see the text, and I can't even see it from here, I'll explain what that is. So there are a couple pieces of information in all these ones and zeros up here. So there is the serial number, which is stored internally as 24 binary bits of data. That block starts here and it ends here. So that's the device serial number. This entire string is sent every single time that device communicates back to the alarm system. So first we have the device serial number. This is who I am. Next, we have 4 bits that determine the loop status. Don't worry about what that means. Just know that it determines the loop status. An RF loop, there's 4 of them on each device. And these photos, thankfully you can see them a little bit. These are pictures of different types of wireless sensors. And what they're actually talking about here is, for example, this device here, this is a wireless magnetic door contact sensor. So it has 2 parts. This part goes into, there we go, it's installed like that normally. This bottom part is installed in the door. This top part, which is a magnet, is installed somewhere else. I'm not going to take them apart right now because it'll set off the alarm, which I don't want to do yet. What it's telling me is that this is triggering loop 1. So every wireless device can trigger one of 4 different states. And it's explaining that if you have this device, you're going to enroll your alarm system to trigger on loop 1, whenever this serial number sends loop 1. And then, there's these other ones, which has, loop 2, loop 3. There's not a whole lot of rhyme or reason to it. So unfortunately, when you're installing these things, it's not intuitive. You really do have to kind of research exactly how they've configured that particular wireless sensor to communicate.
And also the key fob that you can see here, and you can see the picture on the screen, each button is a loop. So they overload the usage of loop to also, that's how we determine which button.
Because these are all hacks. The architecture of alarm systems hasn't changed in almost 30 years. It's all just layers on top of shitty layers. And so when they introduced all this wireless stuff, they had to make it work with systems that were already 15, 20 years installed. So what they had to do is they just used old terminology and tried to, shoehorn this stuff in. And that's kind of why a lot of this stuff doesn't make sense, because they didn't care if it made sense to anyone else but them. Loops operate independently, so one doesn't affect the other. Responses can be custom programmed. So, for example, what I mean by that is this remote control has 2 buttons that says on and off. You would think that means arm the alarm and then disable the alarm, but you can you have to tell the alarm to do that. You have to say, when you detect this serial number and this loop code, do this. It doesn't know that this is a remote control. You have to tell it what it's supposed to do when it hears that signal. So if you wanted to, for some reason, you could tell it that every time a door is opened, it's supposed to arm the system or disarm the system or something. So, you could open a door or something, and that could be like like a duress code. So if you're under duress or if someone is coming to your house, and you don't want them to know that you're going to call the police, you could have a door that you only open when you want the police called, and the system would automatically call the police. You could do anything you want. It's kind of neat. So next we have the device status. Nothing like a Facebook status. There's 4 status bits. That's what they are here. And they determine one of 4 things. Low battery, supervisory, which you don't really have to know what that is yet, wake up or power up, and I have no fucking idea. We try to figure out what it means, but in all of the 80 some odd hours that we spent just looking at binary data on a screen, we couldn't find a single goddamn instance where that 0 was a 1. So I have no idea what it's for. I know it's there, but one day we may figure it out, we may not, I don't know.
This is only a small selection of the hardware that we have. We have 30, 40 devices, and we've never been able to trigger, and we've done some serious, in computer terms, fuzzing of the chips, and we still can't get it to trigger anything, as a 1 in that position. So,
onward. The last bit. This is the most interesting part here. The checksum. The checksum is what's really interesting, and the checksum is what makes our lives not difficult, but more interesting when we're trying to spoof this stuff. The checksum is 16 bits. We've used a lot of experimenting, we'll say, to determine that these 16 bits are a checksum of the preceding 32 bits. So the 32 bits of data leading up to this point is somehow checksummed. It appears to be proprietary. We don't know the algorithm. We've tried very hard to figure out what the fuck it is. We still have no idea. We're going to figure it out at some point, even if it means decapping one of these chips and looking at the gates under a microscope to figure out how it's checksumming. We're going to figure it out, but it is static. There's no timestamp in any of this. So when you press a button on one of these devices, or when one of these devices, like say a door sensor, sends out that signal, it says door open, door closed, it sends out the same exact string, including the checksum, every single time. It never changes. It's always the same. So what that means is even though we don't know how to create the checksum, we can still record checksums from known serial numbers and known loop statuses, and we can play them back successfully.
And we can also, in certain controlled circumstances, change the loop status and create the checksum.
Yeah.
There's parts of it that we've managed to figure out how it's calculated.
Yeah. If you're wondering what you do when you have a proprietary protocol and you're trying to figure out how it works, and all you have are 1s and 0s, and you don't know if there's a pattern or not, what I did was I just put it all into Excel, and I told it to shade everything that was a 1 and not shade anything that was a 0, and it just kind of stared at it until some of it made sense. And believe it or not, that kind of worked for me. But this is just a very small subset of all the data that we were looking at. It's just pretty to look at, I think. It represents weeks of insanity. So let's talk about central office communications. That's communications on the provider side, the people you pay a monthly fee to. Every one of these alarm panels has a built-in dial-up modem, not a very fancy one, but it is there. It's multi-purpose. It's used for a variety of different functions. It's used for remote programming, so they can remotely log into your alarm system. They can dial in, and they can change its settings. It's used for event logging, remote monitoring. So anytime an alarm goes off, obviously they know because the system dials in over the phone line or sometimes over a cellular modem. They can also log, if they wanted to, they can log how often you open or close certain doors. So if you guys are privacy conscious, just be aware that if you have a commercial alarm system, it is possible that they're logging different types of events that are happening within your system. Remote lockout. This is kind of a fucked up feature. So when you buy, at least in the US, when you buy an alarm system, there's usually an upfront hardware fee. So you pay, a couple $100 or something for the alarm hardware, and then you pay like 20, 30, 40, 50, whatever dollars per month in order to get service. And if you cancel the service, all they're doing, by the way, the only thing that you're paying for with an alarm system per month is the monitoring service. All they're doing is they're waiting for your alarm system to call them, and then they call the police. That's it. It's not more complicated than that. And that's what you're paying the monthly service fee for. So if you don't care about that, and you say, well, I just want it to make noise whenever an alarm goes off, or I've set up my computer with an ADT USB, and it's going to call me, it's going to send me an SMS or something. If you cancel your service, a lot of providers will log into your alarm system and they'll shut it down. They'll remotely lock it out, and you won't be able to do anything with it. Maybe, unless
one of us.
Yeah, exactly. There's some other stuff we're not going to get into detail for, just because we don't have time. Compass software. Compass is the name of the software program that looks like it was written for Windows 3.11, probably because it was. That still works today, and this is what they use to remotely program and configure your alarm system. It's one of the most infuriating pieces of software that I've used in the past few years, and we're not going to really talk much more about it other than to tell you it exists. Remote hardware, this, I would think, I don't know for sure, that the alarm company just doesn't have, a couple hundred of these modems all hooked up on top of each other. I'm guessing that they have, some sort of semi-professional bank of modems, but they are all usually Hayes 2400 compatible modems. And it does have to be 2400 baud. It can't be anything faster. If you use a more modern modem, it won't work. I tried. Boy, did I try. Because I didn't want to buy a 2400 baud modem, but I had to buy the goddamn modem. So, anyway. So that's that. System weaknesses. So that's the basic overview. That's how alarms work. If it seemed really simple, it's because it was. Alarms aren't very complicated. They're a lot less complicated than they make it out to be in the movies. So first of all, system weaknesses in terms of programming or installer error. What you can't see here, because of this awesome projector, with apologies to Ekoparty, it's a wonderful projector. It's all my fault. These are all default installer codes, and I will read a couple of them. These are codes that are used for, these are master codes that are used for programming the system. So when the installer connects everything up and they walk up to the panel, they would put in one of these codes to put the system into a programming mode.
And we'll start with the really difficult code, the most complex one first. 1, 2, 3, 4.
Is it 4? Is it 1, 2, 3, 4?
Yeah.
Okay.
1, 2, 3,
It is
4.
a 4, yeah.
Yeah.
There's a bunch of other codes. Each system has a different default code, but these default codes cover pretty much, I would say, every single Honeywell alarm system out there. And if we didn't, I know we didn't mention it already, but this hardware is resold under tens of different brands. So ADT does not, to my knowledge, make their own alarm hardware. Every ADT system that we have seen is actually a Honeywell system with an ADT logo. They provide the service, not the hardware. So these are all different default codes, and one of them that it's a shame you can't see, is actually 4140, which is actually where the title of the talk came from. There are actually over 4,000 ways to break your alarm, but this is a default code that's used for programming one of the most popular systems, which is the Vista 50P. And something that's interesting is that most of the time, not most of the time, often, more often than they should, installers forget to delete the default code from the system, which means they're leaving in a backdoor that came there from the factory, which can be used to program the system, add users, and remove users. It became such a problem that ADT had to, I found this by accident. I found a PDF that I assume was only supposed to go out to ADT installers. I found this PDF online from ADT to their installers that says it's a new standard operating practice. It's a new installer code policy. And it says that if you weren't aware already, you really do have to change the default installer code when you install a system. This is something they had to tell their people because it was such a problem that they weren't doing it. And they created a standard procedure for doing it. But very often these codes are left in, and it's stupid. It's like leaving a default password on your computer, like leaving the admin account blank and then creating a new admin user and putting a password on that.
It got so bad that there's now a new procedure that when the installer comes round and installs your alarm system, he has to call in and give them the new master code. And if he hasn't changed it, they won't pay him.
Yeah.
That's how it works in the US.
There's also something called default ECP addresses. The short version of what that is every device on the ECP bus, any device connected to the hardwired line, has a 2-digit address that identifies the data coming from the device and the data going to the device. And every keypad it's supposed to have its own ECP address, which you program at the time of installation. By default, the Vista 50P and many other commercial panels come with 2 ECP addresses enabled, even though most systems only use 1 keypad. What that means is that most installers will not take the time to delete that second address. And what that means is that someone could then hook up a device, like we're going to talk about what we did, a device like the ADT USB, and they can then interface with the ECP bus using that address, that extra address that was left enabled. It's kind of like turning on MAC filtering on your network and then having a MAC address that everyone knows that you don't use. So if someone wants to get on your network, they just have to change their MAC address to that, and then they can, get by your MAC filtering. It's a kind of a similar concept, if that makes sense to people. Was that a good analogy? I can't tell sometimes. Yeah, maybe? Okay. So, moving on. Short-sighted architecture. What do we mean by that?
4-digit pins. How long since any of us used a 4-digit password? That's it. We can't make it do 5. We can't make it do 6. It's 4 digits. That's it.
But it's hard-coded into the system that your PIN number, the password that protects potentially hundreds of thousands of dollars worth of your assets, must be four digits. It must be 4 characters. And these characters can only be 0 through 9. You can't use more than 4. You can't use less than 4. And this is all hard-coded into the system. You can't change this. There's no software upgrade that you will be able to get to upgrade your alarm system. So you can either deal with it or you can replace it completely with another probably equally crappy alarm system. There's also special functions that exist that are supposed to be useful, but we see them as security risks. One of them is called programming lockout override. So something that an installer is supposed to do when they install the alarm, the last thing they do is they disable the default installer code. There's an option for it. You put in that option and it says, are you sure this will lock out the installer code? After you do this, you only can use the master code to get in. And if you do that, it blocks the installer code. Unless you unplug the alarm system from the wall and plug it back in, and then for the next 30 seconds, the default installer code works. So imagine on your PC, on your server, all I have, imagine it comes with a password of temp123. And, you erase that password, but if I power cycle your server for the next 30 seconds, I can use temp123. It's the same concept. User access level inquiry. This is a term that we made up because we didn't know what other stupid name to call this function. Imagine you have a commercial alarm system and you have 10, 20 different users. They all have different 4-digit pins. Then what you do is you fire someone and you don't realize that, you don't remember to remove them from the alarm system. So later on you find, oh my God, 4625 still works. Who the fuck did that belong to? I don't remember. So they decided to introduce, remember, this is your only interface. You don't have a fancy GUI or anything. You have to talk to the alarm system as a user using just these buttons here and just those 2 lines of text. So they introduced a feature that allows you to ask the alarm system, what is the access level for this PIN number? Now, that's, we can do that on Windows or on any other system too. We can log into the administration console. We can say, hey, user Bobby Tables, what's his access level? And it'll tell you. Except, unlike a computer, the alarm system requires no authentication before performing this function. So all you have to do on a commercial system like this to ask it what the access level for a particular PIN number is, put in the PIN number, put in 4 digits. You don't have to authenticate yourself first, don't worry. Put in 4 digits and then hit ***. And if it's a real PIN number, it'll tell you what zone it's assigned to. It'll tell you what level the user is, if it's a master user, a supervisor, a regular user, and it'll tell you its access, what number user it is. On the list of users, what number user is it? And if the user code doesn't exist, it doesn't do anything. It gets better, don't worry. Why does it get better? Because you figure if you put in a stupid function like that, surely you must have brute force detection, right? So if someone sits there and does this for like 4 hours straight, the system knows, hey, slow down. You're probably not the real guy who's supposed to be using the system.
Guess what?
You'd be wrong. There's no brute force detection.
Nope.
There's no brute force detection, and you figure, okay, well, geez, Babak. All right, fine. Then at least the system has to be disarmed, right? When you do this. You have to have the system disarmed before you ask it, what users have access, right? You can't do this while the system's armed.
Guess what? Yes, you can.
So, yeah, and you can't turn off that feature either, by the way. It's a built-in feature that you can't turn off. It's not a bug, it's a feature. So what we found is that these systems have minimal attack resistance. They were not designed to be hardened against targeted complex attacks. They were designed to be hardened against brute force attacks, against attacks from people who are breaking windows or breaking physically into your building using the rules that all robbers use. You have to break down the door. You have to break a window. You're not allowed to hack the system. That's not part of the game. That's not in the rules. RF jam detection is also a weak point, and I'll talk about that. Why they have crappy jam detection. And as I mentioned, there's no attack resistance on the ECP bus. The ECP bus is clear text. It's not encrypted. There's no detection for hey, there's weird stuff going on the bus. Maybe I should alert someone. ECP bus shortcomings, as I mentioned, it's unencrypted. It's shared copper, meaning that every device, in this alarm panel, there's a lot of, if you guys come up here afterwards, if you're interested, there's a lot of little wires and nodes here. It looks really cool. And then you realize that the ECP bus is only 4 terminals. That means every single one of these keypads all connect physically to the same.
Seguridad y cybersecurity. Después encontré este número de Rusia que no sé si será real, pero bueno, me da para mencionarlo, que es 127 millones en lo que es solamente cyber warfare. Y bueno, pasemos ahora a ver por ahí la gente que hay detrás, cuánta gente tienen en lo que es cyber alarm y en todo lo relacionado con defensa a nivel país. Por ejemplo, el GCHQ tiene 5.000 personas número importante. La Agencia de Seguridad Nacional de Francia tiene 230 empleados. Esta es solamente la Seguridad de Sistemas Nacional de Francia. Después la misma tipo de agencia tiene 700 empleados en el Reino Unido y en Alemania 500 empleados. Después el Army Cyber Command de Estados Unidos, total parece que tiene 21.000 personas, entre soldados y civiles, todo alrededor del mundo. El total de Cyber Workforce, o sea, todas las personas que trabajan por ahí en sistemas, no solamente en ataques, son 17.000 personas en la parte aérea, en el Army 11.000, 14.000 en la parte naval, etc. Como pueden ver, mucha gente atrás de todo lo relacionado con Cybersecurity. Bueno, después también estos datos que pueden ser medio dudosos. Rusia tiene 7.300 personas. Y bueno, después de un informe del FBI, que quién sabe si es verdad o no, puede ser armado, ya saben para lo que digo, para generar esa necesidad, esa urgencia, que bueno, que China tiene 180.000 cyberespías, que llamaban en el informe, que 30.000 son militares y el resto son privados, o sea, civiles que son contratados por el gobierno de Chile. Y bueno, de los militares está el famoso Cyber Blue Team de China. Ya tenemos una fotito supuestamente del Cyber Blue Team. Se ve que son varios y todos quietitos ahí lanzando exploit y buscando 0Ds. Pero bueno, como pueden ver, en algunos países es real, digamos, que están construyendo cada vez más secciones dedicadas exclusivamente para lo que es defensa y ataque en todo lo que sea relacionado con los cyber, le llaman el dominio, la dimensión cyber, dominio cyber, no recuerdo. Bueno, después de ver todos estos números y toda esta plata que se gasta, yo dije, bueno, ¿cómo estamos en Argentina? Y la verdad que no sé que haya un Cyber Army acá en Argentina. Creo que, no sé, el tanque más viejo que hay debe ser del 70. Creo que, según tengo entendido, no se invierte mucho en la parte del ejército. Pero bueno, por suerte investigando me quedé un poco más tranquilo porque China parece que está haciendo un acuerdo con Argentina. Argentina y China están haciendo un acuerdo para no sé qué. Es militar, digamos. Entonces, capaz que si no hacen algo, los llamamos a los chinos y nos defienden. O sea, acá pueden ver cuando estaban en el acuerdo, está el ministro argentino con el ministro chino saludándose y ahí no se pueden leer los pensamientos. Yo me pregunto, en un acuerdo entre China y Argentina, entre dos potencias tan dispares, digamos, siempre cuando uno hace un acuerdo busca obtener un beneficio de la otra parte, digamos. Yo de Argentina, desde China hacia Argentina puedo ver un montón de beneficios, digamos, de que China nos provea cosas, nos ayude, pero de Argentina a China, digamos, no sé qué les podemos proveer, digamos, no sé. Entonces hay que ver, digamos, qué hay atrás de este acuerdo, qué les conviene a los chinos y qué nos conviene a nosotros, ¿sí? Entonces, bueno, por lo menos mientras sean amigos los chinos está todo bien, podemos estar un poco más tranquilos. También me preguntaba si tenemos cyber weapons, cyber armas, ¿qué cyber armas podemos tener? Y la verdad que si no tenemos, por empezar, cyber army, nos vamos a tener cyber weapons. Por ahí se me ocurrió algo que podría ser, digamos, de cyber weapon, digamos. No sé si va a ser muy efectivo para atacar otra computadora, pero seguro te rompe la cabeza con la netbook. O sea, si alguien sabe que tenemos cyber weapons, me dice y las podemos agregar aquí. Después, también... disculpen. Yo preguntaba, bueno, no tenemos cyber army, no tenemos cyber weapon, pero tal vez no tenemos mucho que preocuparnos porque tenemos buenas defensas, digamos, tenemos las cosas protegidas, las empresas son cuidadosas, tienen buena seguridad, digamos, la infraestructura crítica no está muy expuesta, entonces... Está bien, nos pueden atacar, pero nos las bancamos porque tenemos todo más o menos seguro. Entonces me puse a hacer una investigación, buscar cosas en Google, simplemente de lo referente con infraestructura crítica. Por ejemplo, empresas proveedores de energía. Ustedes saben que si a un país le cortamos la energía, ese país deja de funcionar. encontré cosas bastante interesantes. Acá pueden ver un oleoducto en Tigre y habla de sistemas SCADA, la implementación, y podemos ver todo el diseño que se implementó, los equipos que usan. Todo está disponible en internet para el que quiera saberlo. Porque hay una empresa que le vendió esa solución y lo publica. Después tenemos un sistema SCADA para Edenor. También nos dice qué sistema SCADA se implementó para resolver tal problema, etcétera. Y también nos muestra el diseño de lo que se implementó, cómo está implementado, para que toda la población sepa de cómo se maneja todo lo referente a energía. Después también tenemos Transcender, que es una distribuidora de energía a nivel nacional, que también nos muestra un poquito de diseño de sus redes internas, algunos diseños de circuitos internos de otros dispositivos. Pueden ver diseños de las redes, los switches, cómo están conectadas. Después tenemos Camesa, otro distribuidor mayorista también. Todo esto es el mapa de la red eléctrica del noreste y centro argentino. Cómo están interconectados entre las distintas ciudades, cómo sale a Brasil, a Uruguay. Después tenemos acá de NARSA, también nos facilita algunos de sus sistemas, cómo están configurados, cómo están conectados, con planos. Después tenemos Edenor, lo que es Smart Grid, nos muestra cómo ellos implementan Smart Grid, qué dispositivos usan, cómo están conectados, qué tipo de modem, etc. Y por último tenemos Siemens, que nos muestra una solución que le vendió a Solalban, es una empresa creo del noroeste. Nos muestra todos los dispositivos que le vendió, cómo están conectados, cómo se relacionan, por ejemplo, con la parte petroquímica de la empresa, con otra parte. Esta es una empresa que vende energía en el noreste, creo. Que Siemens, lo publicó. Como saben, Siemens era el que lo vendió los dispositivos a Irán, que tenían los que atacó Stuxnet. Entonces, como pueden ver acá, Siemens lo publica en internet, lo que le vende a un gobierno, a una empresa, por eso. O sea que, como ven, no es muy difícil conseguir este tipo de información. Entonces, como ven, en Argentina estamos bastante protegidos, es muy difícil saber cómo está diseñada la red eléctrica, los sistemas que usan, cuesta un montón de trabajo conseguir esta información. O sea que podemos dormir en paz, tranquilos. Acá algo interesante también relacionado con lo de ciberdefensa que encontré. Hace poco muchos habrán sido víctimas del corte de servicio de Movistar, que dejó durante 4 horas a todos los usuarios sin servicio, que parece que fue un ex empleado que desde su casa, ahí dice antena anostation, que debe ser nanostation, son la antena de largo rango Wi-Fi, que de su casa parece que ingresó al sistema y desconfiguró los switches y reventó todo el país quedó 4 horas sin servicios y le pusieron una multa de 6 millones a Movistar. Con esto que quiero mostrar que pueden ver alguien, un ex empleado o empleado, no sé si era empleado para ese tiempo o pasó a ser ex empleado después que lo echaron, después de hacer esto. Fíjense, fácilmente desde su casa dejó a millones de argentinos sin servicio de teléfono móvil, que como saben, es algo que se usa cada vez más para negocios, para comunicación hogareña, para lo que sea, para internet. Pero es algo grave, poder que alguien tan simplemente de su casa, por más que haya sido empleado, pueda dejar sin servicio a millones de personas por tantas horas, es grave, muy grave. Otra cosa que también encontré que pasó algo similar con Claro, que ustedes por ahí me van a decir qué tendrá que ver esto con seguridad. Pues también Claro tuvo un corte, le metieron una multa por 500.000 pesos y le dio crédito a los clientes por el tema del corte. Y el corte supuestamente fue porque la gente del gobierno de la ciudad en una obra le cortó una fibra óptica subterránea. Entonces ustedes me dirán, ¿qué tiene de relación esto con seguridad? La verdad que no. Es difícil por ahí encontrarle cuál es la relación. Pero yo se la voy a decir a la relación para que vean qué sutil por ahí es todo lo relacionado con seguridad, con ciberataques, que por ahí no se ve, Porque, por ejemplo, esta gente que cortó el caño, que estaba haciendo un trabajo, Estaba haciendo un trabajo, entonces no sabía que estaba el caño y estaba acabando y rompió el caño. ¿De dónde sacó las personas esas que tenían que ir a trabajar ahí? Sacó de una orden de trabajo. ¿De dónde sale la orden de trabajo? Sale de una computadora. Supuestamente que el gobierno de la ciudad esté informatizado a ese nivel y organizado a ese nivel. Pero bueno, supuestamente cada cuadrilla para ir a trabajar saca la orden de trabajo que le dice qué es lo que tiene que hacer. Entonces, ¿qué pasa si yo hackeo los sistemas del gobierno de la ciudad, que seguramente deben ser recontra seguros, debe ser muy difícil, pero bueno, ¿qué pasa si yo los hackeo? Y emito una orden de trabajo que le digo, vayan a cavar ahí un pozo de 20 metros, tienen que hacer porque vamos a hacer tal cosa, y bueno, resulta que por ahí pasa un caño de fibra óptica que deja media Argentina sin internet o sin servicio de telecomunicaciones, o pasa un oleoducto, un gasoducto. Los tipos van a ir, dice, bueno, cabemos acá 20 metros y cavan ahí, digamos, no la piensan mucho. Entonces pueden ver por ahí que el eslabón más débil en la cadena puede llegar muy lejos, digamos, puede ser algo que ni se nos ocurra a nosotros, digamos. Podemos lograr realizar un ataque, un ciberataque que tiene consecuencias muy graves, pero en algo que por ahí nunca se le va a ocurrir a nadie, digamos, y es muy sencillo. Hay mucha gente que está hablando del tema, bueno, de hacer un tratado contra cyberweapon, así los países no se arman y no se lanzan exploit de uno al otro y no hay problema. No sé con qué objetivo detrás, pero digamos, si a esto por ahí hacemos una analogía con lo que es el tratado, por ejemplo, contra armas nucleares. ¿Cómo fue este tratado? Bueno, eran, no sé, 5 países, creo que era Rusia, Estados Unidos, Francia, China y no me acuerdo más. Bueno, decimos, vamos a hacer este tratado, nosotros tenemos armas, nos comprometemos a disminuir nuestro arsenal, total tenemos para volar el mundo 500.000 veces, lo vamos a dejar para volarlo el mundo 100 veces nomás. Pero los otros, los que no tienen armas, no van a poder hacer más. Nosotros nos quedamos con lo que tenemos, pero ellos no pueden hacer más. Y vamos a impresionar a todos, y el que quiera hacer armas lo vamos a joder. ¿Cómo pasa con Irán? A Irán, no sé si está queriendo hacer armas nucleares o no, pero bueno, como ven, le ponen restricciones, le joden todo el mundo, le mandaron Stuxnet, etcétera, le matan personas. ¿Por qué? Porque está haciendo armas nucleares y eso está prohibido. Entonces, ¿qué pasa? Yo digo, ¿qué pasa si se hace un tratado contra cyberweapon que no se puede hacer? Digamos, que va a ser también como un arma en sí mismo, porque va a decir, bueno, nosotros ya tenemos cyberweapon, nos quedamos con la que tenemos, los demás no pueden hacer. Y el que quiera hacer, lo reventamos. Porque no. Nosotros ya tenemos el tratado, o sea que eso mismo se puede usar como un arma. Otra cosa, es imposible probar quién tiene o no, digamos. O sea, no es como armas químicas o armas nucleares, que es algo físico, ¿no? Esto no es físico, o sea que es imposible de probar. Entonces nos preguntamos quién nos beneficiaría. Lo primero que se me ocurre es a los que ya tienen, o a los que tienen más poder de manejar esto por detrás, digamos, que tienen más poder de poner las condiciones en el tratado. También se está hablando, mucha gente como que quiere que haya leyes contra 0 days, que no se puedan vender los 0 days, que sean ilegales, etcétera, que no estoy de acuerdo. También está ese movimiento. Todo esto, por supuesto, si llegan a haber un tratado contra cyberweapons, leyes contra 0 days, todo esto va a tener consecuencias, que por ahí la gente que fomenta estas cosas no piensa en las consecuencias, o piensa solamente en el lado ideal, en el lado bueno, que va a ser para mejor, pero no piensa en las consecuencias. Entonces yo pensaba en posibles consecuencias, ¿no? Este es un formulario de la visa para Estados Unidos, que ahora creo que no se está usando más, pero hace unos años se usaba, porque yo me acuerdo de haberlo llenado. No sé si no, para otros tipos de visa capaz que se usa, o en otros países, que tenía una pregunta interesante, que decía, ¿tiene usted alguna habilidad especial o entrenamiento, incluyendo, entre otros, en armas, explosivos, alguna experiencia en armas nucleares, biológicas o químicas? ¿Sí o no? Explicarle. Por supuesto que si ponían sí ahí, la visa no sé si se la daban, pero seguro que cuando llegaban a Estados Unidos lo hacían pasar al cuartito. Entonces yo digo, si hay luego una ley contra 0 days, o si hay un tratado contra cyberweapon, ¿qué pueden poner después en el formulario? Algo así, aunque diga, alguna vez usted ha estado en contacto con 0 days o ha creado exploit, y si uno contesta que sí, vamos para el cuartito, ¿no? Parece una locura, pero no sé. Entonces, si pasa eso, yo también digo, bueno, entonces ¿qué va a ser mi prontuario? Cuando yo llegue, por ejemplo, a Estados Unidos, dice César Cerrudo, prontuario, venga para acá al cuartito. También por haber vendido 0 days, también venga para el cuartito. no sé, digamos, parece una locura, pero bueno, cuando ustedes ven cosas como esta, dicen, bueno, ¿qué tan locura será, digamos? Matar a un científico porque trabaja con cosas nucleares, digamos. Esto es una realidad y todo surge por ahí de un tratado contra la proliferación de armas nucleares, un país que es enemigo de dos países poderosos y resulta que le terminan matando gente de la forma más cruel que puede haber, con atentados, gente que no tiene nada que ver, son científicos, y esto es real. Entonces, cuando uno empieza a hacer movimientos para conseguir algo, tiene que pensar en las consecuencias no tiene que idealizar las cosas, tiene que pensar que vivimos en un mundo que es imperfecto y que puede pasar cualquier cosa. Espero que esto nunca llegue a pasar contra los proprietary y los researchers, porque si no, varios de acá vamos a terminar mal, ¿no? Bueno, quería tratar algunos mitos o verdades sobre Stuxnet. Y mucha gente dice, bueno, costó $1 millón, costó, no, entre 5, de 10, más de 10. Como les decía, digamos, tiene una parte que es software. Digamos, es software, tiene el mismo costo que hacer cualquier software. Es software. Puede ser innovador, bueno, será innovador. Bueno, después tenemos los 0 days. Bueno, los 0 days sí, serán costosos, depende de dónde salieron, bueno, son costosos. Entonces, si me quedo con un número, me quedo con un número de 1 millón. Digamos, me cierra y la mayor parte capaz que costó los 0 days. Si los 0 days no fueron tan costosos, entonces menos costó, porque es software. Bueno, lo de inteligencia previa, bueno, ya estuvimos hablando sobre el tema de inteligencia previa. Después, bueno, que era súper sofisticado también, bueno, será sofisticado, pero bueno, es software, digamos, no es lo mismo que el malware común que bueno, lo usan los criminales para robar contraseñas del banco, etcétera, usan lo más fácil, lo más económico, pero bueno, esto es un poco más sofisticado, pero es software, al final de todo es software. Después hay otro mito que dice que, bueno, que debido a un error que tenía se propagó por Internet. Esto no es cierto, digamos, no tenía ninguna funcionalidad para propagarse por Internet. Digamos, esto creo que también lo publicó el tipo que escribió el libro. Entonces todo el mundo después lo repite y no es cierto, digamos. Bueno, finalmente, bueno, que fue creado por usuarios. Por supuesto no hay la más mínima prueba, digamos, puede haber indicios, puede haber sospechas, pero bueno, no hay pruebas reales que indiquen que esto sea cierto. Entonces no hay por qué afirmarlo como cierto. Después unos datos curiosos y no tan curiosos, que ya, bueno, en este caso esto ya lo dije, bueno, es imposible, digamos, afirmar a alguien que realice un ataque, porque bueno, ustedes sabrán, se puede usar un sistema como proxy, no podemos hacer pasar por otro, etcétera. Es imposible afirmar, atribuir quién hizo un ataque. Algunos dicen, no, sí, pero si tenemos inteligencia previa, entonces podemos sí saber que el ataque lo hizo tal, porque teníamos inteligencia previa. Pero bueno, ¿cómo se obtuvieron las pruebas de la inteligencia previa? ¿Y qué pasa si yo sé que vos tenías esa inteligencia previa, pero es otro el que hace el ataque que coincide con esa inteligencia previa porque yo ya sé que la tenías? Entonces tampoco es algo que se pueda usar para atribuir ciertamente la inteligencia previa. Algo muy cierto es que esto es, en lo que es cyberware, es totalmente asimétrico, o sea que con muy poco se puede hacer mucho, con mucho se puede hacer nada. Por ejemplo, un país muy poderoso como Estados Unidos, que quiere atacar a un país que no está desarrollado, que no tiene muchas comunicaciones, no usa mucho internet, no le puede hacer nada por el lado de ciberataques porque, bueno, no está muy desarrollado. Pero en cambio ese país sí le puede hacer gran daño a Estados Unidos porque Estados Unidos está muy desarrollado en lo que es tecnología. Como ahí puse, bueno, un chico de 12 años en la otra parte del mundo con una PC, no sé, una 386, que con un modem o algo conectado a internet puede llegar a hacer grandes cosas, grandes daños. Otra cosa interesante es que Estados Unidos constantemente a las empresas le está pidiendo información sobre personas, por ahí sin tener justificación. Esto debido a las leyes, el Patriot Act y otras leyes de antiterrorismo. Se van a una empresa y le dicen, Google, a ver, dame la información de Juan Pérez, y Google se la da. Entonces esto va referente a lo que gente de empresas que tienen cuentas en servicios de Estados Unidos, bueno, eso no tiene mucho de privacidad.
Close the door, stop jamming, and you're good. Or if you're trying to jam a motion sensor, continue jamming while you're walking through the room, and then you stop jamming. Unsupervised RF transmitters. That unsupervised means a transmitter that doesn't have to check in, that doesn't have to be monitored or supervised.
Like the key fobs that you put in your
the
pocket.
remote controls. Obviously, if you're going to be away from your house for 5, 6, whatever hours, you're not going to be near the alarm system. So It doesn't make sense for those types of devices to check in. Pardon me. So attack vectors, eavesdropping. Remember, it's sent in the clear. All these signals are. So, for example, when Keith was in Washington, D.C. earlier this year, originally speaking about this stuff, for fun, he hooked up the hardware, and he looked at it in promiscuous mode, and he saw, how many different systems did you detect?
I don't know. I saw about 20-something different sensors. I was on the 15th floor of the hotel, looking out towards a residential area, and from the behavior of the sensors, I could tell that one of them was a motion sensor. Because when there was a good program on TV, nothing was happening. And then when the commercials came on, the sensor started working.
So
you can gather intelligence if you look at it from a commercial point of view. If you can see what the sensors are doing,
you know what's happening inside the building. I mean,
you
that
know if there's somebody in the room
is being broadcasted. Think about that. You're just yelling, there's someone here, or there's no one here. Jamming, so you figure, okay, surely they could do jam detection, right? Yeah. Well, old receivers don't have any jam detection. And they realize that, hey, this is kind of a problem, so let's put jam detection in our receivers. Awesome. Let's turn it off by default. Even better. Yeah. When they turn it on, let's make sure it doesn't check all the time, even though we have a constant power source. Let's only check every 45 seconds. So it only checks every 45 seconds for a jam condition when you turn it on. And the jam detection is so unreliable that I don't recommend turning it on because there's too many false alarms. I turned it on in my own house, and it had way too many false alarms, even when I wasn't jamming. So,
does anybody have a wireless weather station or something that interferes with these systems?
All right. So Leonardo looks very, very stern, and I got to go really fast now. So Bi-Directional Rf Transmitters, that's keypads. You can have wireless keypads. There's two kinds. Just know that there's two kinds. There's unencrypted keypads. Good idea, right? It uses a house ID. It's a 2-digit code that assigns, your system. And it tells you what those are, and then you pick one that isn't that, and then you have your own house ID. Encrypted keypads, we believe, use key lock encryption from Microchip. It's the same encryption that's used by cars for alarms, from the manufacturer, by garage door openers, by other alarm systems, and it was broken in 2007. We've still not played with breaking it too much, but it's still under investigation. It doesn't work when you have the microphone on your face, I realize. So the communication between the alarm panel and the central office through the phone line is a 2-part authentication. So when they dial in, the alarm system requires 2 pieces of information. One of them is the subscriber account number. The other one is, which is 4 bytes, 4 hexadecimal bytes. The other one is a central station identification, or CSID. It's also hex. It's actually 8 bytes. Those are programmed when you install it. ADT systems, which have their own firmware, same hardware, just their own custom firmware, they decided to change it up and do something different because they figured it was way too secure to have 2-factor authentication. So what they did, and this is hearsay. I haven't seen this in person. Unfortunately, I've only been able to research it a little bit. But from what I can see, it appears that the only 2 things that you need to connect to an ADT system are the subscriber account number and just their special version of the Compass software. So to the best of my knowledge, ADT systems use single-factor authentication they think it's 2, but as long as you have their special program, then you only need 1 piece of information about the target alarm system.
Which is written on every piece of paper from the alarm company,
right.
Your billing statements, everything.
The phone calls supposedly are encrypted, since whatever encryption this is was in use almost 30 years ago. I'm guessing it's not very strong, but we haven't had a chance to look at it yet. The protocol and algorithm and all that are unknown. Mitigations. You need an alarm system. What the hell are you going to do? If 90% of the alarm systems are all this hardware, and it sucks, what do? You can't just get rid of it. That doesn't do anything for you. So the best thing you can do is make sure it's properly installed. Hide your wires and protect them. Make sure the wires aren't exposed to anyone very easily. Obviously, if someone is inside your building, then they have a higher level of access than someone else who is still trapped outside, like at night. But it doesn't mean you have to make it easy for them. Put your wiring in conduits. Put it through walls. Make sure it's kind of hard to see what's going on.
Don't just lay it over the top of the false ceiling.
Yeah. Don't use wireless devices if you can avoid it. They're really not very good. We want there to be better devices out there, but we haven't seen them yet. They may exist, but I haven't seen them yet. So if you have this type of system, just stay away from the wireless stuff. If you're really worried about security and it's not just convenient, stay away from the wireless stuff. Know your weak points. This is true of any security system, whether it's your computer or your network or your alarm system. Know the vulnerabilities. Know what it can do and what it can't do, and think about it accordingly. Understand what the different attack vectors are and plan around them. Protect your power source. Remember, when you power cycle an alarm system, if the battery is dead for some reason, or if they can disconnect the battery for some reason, then that means that the default code is re-enabled no matter what. And you can't stop that from happening. So protect your power source. Make sure all your security systems always have a secure means of constant power. And physical access is bad, obviously. You don't want anyone to have physical access to that stuff. So, caveat, everything here is a work in progress. This is all active research. If you talk to us in a month and a half, we'll have 10 other things to tell you about alarm systems. So this is just what we happen to know right now. There's more stuff coming. There's going to be other systems we're looking at. None of this stuff is vetted by anyone but us, so it's possible we got some stuff wrong. So if you know we got something wrong, just tell us, and we'll correct it. Research is restricted in scope for so far. We did have to buy for all this stuff out of pocket. It's not cheap. And so we haven't had a chance to look at everything necessarily. The information is obviously only applicable to the hardware that we have seen so far, which in this case happens to be systems from Honeywell Ademco, which is the same brand, which is also marketed under a million other names. But this stuff doesn't necessarily apply to other brands of systems, which should be obvious, but I guess we have to say that. So that's it. Thank you very much. My stuff is here on the left. If you want to find me on Twitter, I'm @ and then my name. Very clever, right? Babak Javadi. If you want to talk to Keith, Keith is over here. You can reach him at Gmail. We both have PGP, being no one ever uses it, but we have it. So thank you. Yay.
Any questions?
2 questions? Do we have time for like 1 or 2 questions? Maybe?
It's your coffee break.
No.
If you want to ask questions.
He says no.
Yeah.
That face says no.
Ya 10 minutos para el coffee break.